Hi, okay, let's go over Chapter 17, Chapter 17, Problem 22. Alright, Problem 22 asks you to calculate the pH of a buffer that is 0.105 moles per liter of NaHCO3 and 0.125 moles per liter of Na2CO3. And so the first thing I'm going to do in this problem is I'm going to look at what I have here. So I have basically two salts, but I see that when they break down, I'm going to have HCO3 minus and just CO3 2 minus. And so here I can see, okay, these two things are conjugates of each other. They're both going to exist in this buffer, and what a buffer needs in order to be a buffer is the conjugate, a conjugate acid and a conjugate base of each other. And so I know I have some amount of conjugate acid and some amount of conjugate base. And so what I'm going to do with this type of problem is I'm basically going to set up, I could set up an ice table, something like that, with the acid breaking down. So I have HCO3 minus, and I know it's going to break down into H plus and CO3 2 minus. Ice. And so initially I'm going to have 0.105 moles per liter of HCO3 minus, 0H plus, and 0.125 moles per liter of CO3 2 minus. That comes from right here. I know there's going to be some change. And again, this is a weak acid, so I can just ignore the X there. And I'm going to find my Ka. Now when I look in the book, I notice there's a Ka1 and a Ka2. I also notice this acid is already charged, so one of these protons must have already come off, right? I know it came from a salt, but it could still come from, or could actually take on another proton, right? And so this is actually going to be the Ka2, and my Ka2 for this case is 5.6 times 10 to the negative 11. Again, I'm just going to solve for x. That was the most complicated part. And my pH will equal 10.33. Okay, let's solve for B. That was A. So 22B says calculate the pH of a solution formed by mixing 65 milliliters of 0.20 molarity NaHCO3 with 75 milliliters 0.15 molarity Na2CO3. I'm not going to work this entire thing out because it's pretty much the exact same. The added step here is that you need to calculate how many moles you actually have. Okay. So you have 0.065 liters times 0.20 moles per liter of NaHCO3, right? And 0.075 liters times 0.15 moles per liter Na2CO3. And so from there, you'll calculate the number of moles, plug everything back into an ice table, just like we've been doing. Before you rearrange to solve for x, in the Ka solution, remember these must be the concentrations, not just straight up moles. So I think you have everything you need to be successful on this problem. The final answer for B is going to be the pH will be 10.19. That way you'll know if you plug everything in right.